Hi everyone, this is Mrs. T from Mrs. T's Chem Talk, Regents Chem. In this video, I'll do a Regents review video where we will go over numbers 51 to 85 on the January 2017 Regents. In our class, we called this the Violet Regents, this will also include all of Part B2 and Part C. For those of you who don't know who I am, my name is Mrs. T. My name is Beth Tuminello. I'm a chemistry teacher at Calhoun High School in Merrick, New York. Parts B2 and C. For number 51, it says explain in terms of electron configuration why arsenic and antimony are chemically similar. So when they give us this phrase in terms of, we need to be really careful because whatever comes after it needs to be mentioned in some way in your answer. So we need to look up the electron configuration of arsenic and antimony in order to answer this question. So the first place that we're going to do, or the first place that we're going to go is table S, because I maybe don't remember which symbol goes with arsenic and which symbol goes with antimony. So if we look way down here on table S, it says that arsenic is AS. And as we scroll further down on table S, we can see that antimony has the symbol SB. So we are going to look up the electron configurations of AS and SB in order to complete this question. So that means that the next place we need to go is the periodic table, and we're going to locate AS and SB. And on table S, we could also see that AS had an atomic number of 33 and SB had an atomic number of 51. That information is also on table S, and that makes it easier for us to find these different elements. And if you notice, AS and SB are in the same group. Now, we said that elements in the same group, that's also called a family, because they are going to have similar chemical properties. And the reason for those similar chemical properties is that these elements that are in the same group also happen to have the same number of valence electrons. For arsenic, we have 2, 8, 18, and 5. And for SB, for antimony, the electron configuration is 2, 8, 18, 18, 5. So each element, arsenic and antimony, they have the same last number, the same last number in their electron configuration. Having the same last number in their electron configuration means that they have the same number of valence electrons. So they have similar chemical properties because they have the same number of valence electrons. For number 52, period 3, unreactive gas at STP. Remember, these unreactive gases are in the noble gas group, which is group 18. And if we want to find which noble gas is in period 3, we're going to look at the periodic table. Remember that periods are the horizontal rows that go across. And this would be the members of group 18, my noble gases. So argon is the element that is in group 18, but also in period 3. So for this particular question, you can say argon, you can say element number 18. You can use the symbol AR. Okay, any of those ways to identify argon would work in order to get credit for this question. For number 53, it says compare the energy of an electron in the first shell of a cadmium atom to the energy of an electron in the third shell of a cadmium atom. Now remember, these electrons are not in fixed paths. They're in orbitals, which is areas of high probability, even though we draw them like a Bohr model. But we said the first shell is closer to the nucleus, and the third shell would be further away than the first shell. And so the ones that are further away have more energy, and the ones that are closer have less energy. Electrons in a closer shell have less energy. Electrons in a further shell have more energy. For questions 54 and 55, it's going to be based on this information and on your knowledge of chemistry. My suggestion when they say something like that, where 2 questions or 3 questions are based on the same information, reread this information for every question that it's based on. Every question that they list, you want to reread this information when you do those questions. So it says the density for 2 forms of carbon are listed in the table below. And it says to compare the number of carbon atoms in a 0.3 centimeter cubed sample of graphite to a 0.3 centimeter cubed sample of diamond. We said that more dense means smaller volume. We can get that from the formula D equals M over V. So the more dense something is, the more massive it is for less volume. If we look, carbon is more dense, so it takes up less volume. Graphite, sorry, I did that backwards. Graphite is less dense, and diamond is more dense. We're comparing these numbers here. If it's less dense, the volume is larger. If it's more dense, the volume is smaller. So if we're taking the same volume, the one that has a higher density has more atoms because they're closer together. So diamond has more atoms in the sample. More dense means, because these 2 atoms have the same mass per atom, more dense means that there's more atoms in the same volume sample. It says the student calculated the density of the sample to be 2.3 grams per centimeter cubed, and if we look back up at the table, remember we always want to look back, the accepted value is 2.2 grams per centimeter cubed. So accepted is 2.2 grams per centimeter cubed. It says show a numerical setup for calculating the student's percent error. What we're going to do when we calculate percent error is look for the formula on table T. On table T, it says percent error is measured value minus accepted value over accepted value times 100. The measured value is the student's value minus accepted over accepted times 100. So if we take the student's value of 2.3 minus the accepted value of 2.2 and put it over the accepted value times 100, this would be the final answer because a numerical setup means show the math. All you need is numbers. (56) and 57 are both based on this information, so you want to make sure that you reread the information for number 56 and number 57. It says a sample of calcium carbonate has a mass of 42.2 grams. Calcium carbonate has a gram formula mass of 100 grams per mole. Show a correct numerical setup in the sample of CaCO3, or calcium carbonate. In order to do this question, we want to look at table T, and we want to look at the mole calculation formula. Number of moles is equal to given mass over the gram formula mass. When we plug that information, when we plug the information from the problem in, the given mass is 42.2 grams. The gram formula mass is 100 grams. This would be the correct numerical setup. All you need to do is do 42.2 over 100 to get the number of moles, and that would be according to the formula that's given. Then it says determine the percent composition by mass of oxygen in calcium carbonate. So I'm just going to do that one up here so we can still see this information. So this is going to be for number 57. If we want the percent of oxygen, once again, we need to use a formula on table T. On table T, we have the percent composition formula. And percent composition equals mass of part over mass of the whole times 100. So in order to get the mass of my part, we want the percent composition by mass of oxygen, CaCO3. The mass of oxygen is O times 3. So if I look at my periodic table, I can see that oxygen has a mass of about 16. I'm going to take 16 times 3 to get the mass of oxygen in this compound, which is 48. That part is going to go over the mass of the whole, which is the gram formula mass, times 100 to get the percent composition by mass. And what that is, when we multiply it out and divide it out and multiply by 100, we wind up getting 48% oxygen in this compound. 58 and 59 are both based on this information about carbon monoxide, and it says carbon monoxide is a toxic gas found in automobile exhaust. Concentration of carbon monoxide can be decreased by using a catalyst in the reaction between carbon monoxide and oxygen. This reaction is this reaction is represented in the balanced equation below. The question says, explains in terms of collision theory, why increasing the temperature increases the rate of reaction. So again, remember, whenever they give you something that says in terms of, we need to mention something about collision theory. Remember that collision theory states that in order for a reaction to happen, particles must collide. Those collisions, in order to be effective, must have enough energy and proper orientation. That energy has to meet the activation energy. So if they have at least enough energy and they hit in the right spot, the collision will be effective. Increasing the temperature increases the number of collisions that have enough energy. It increases the overall average kinetic energy of the molecules, meaning that the molecules will have more energy when they hit and more of those collisions will be effective. For number 59, it says, on the labeled axis below, draw the potential energy curve for the reaction represented by this equation. So we need to look at the reaction. And if we look at the reaction, the energy term is in the products. If the energy is a product, that means that we're talking about an exothermic reaction. An exothermic reaction means that energy is released. Exothermic is always going to be downhill. So we want to make exothermic we want to make a downhill potential energy diagram. So we start with a line, go over a bump, and then we're going to end lower than we started because it has to be overall downhill. Remember, if you write the word fox and put an axis around the X before you cross it, that is your exothermic potential energy diagram. It can't be just any word, okay? It has to be fox, ox, box, something with an O in front of the X to get your exothermic. But again, remember that exothermic is always downhill. For number 60, it says 60 and 61 are based on the information below. So once again, if you are doing a question that information is based on more than one question is based on the information, you want to reread for every question in the set. You don't want to miss something from the reading for a later question. So it says represents gas and the conditions of pressure, volume, and temperature in a rigid cylinder with a movable piston. This sounds to me like they're mentioning pressure, volume, and temperature, which means it's probably going to have something to do with P1 V1 over T1. If we look on the back of the reference table on table T, we have that P1 V1 over T1 equals P2 V2 over T2 formula, the combined gas law. It mentions pressure, volume, and temperature. Remember, temperature has to be in kelvins when we do or use this formula. Oops, I wrote Kevins. We also know that it says, if it says something about STP, STP is on table A. And as we look at table A, standard temperature, we're only going to use kelvins, is 273 Kelvin. And for the standard pressure, we're going to look and see which pressure unit is in the question. The pressure unit that's in the question is atmospheres. So we are going to write down standard pressure as 1 atm. But again, you're going to use the pressure unit that was already used in the problem. So since this problem mentioned pressure in atmospheres, we're going to use standard pressure in atmospheres. So my P1 is my first pressure, which is 1 atmosphere. My V1 is 2.5 liters. My T1 is 298 Kelvin. They say they're moving it to STP, so my P2 is still 1 atmosphere. My V2 is what I'm looking for, and my T2 is my standard temperature of 273 Kelvin. These stayed the same, so they don't need to be in the math. Kelvins and kelvins cancel. My answer comes out in liters. I put my V1 over my T1, and I set it equal to my V2 over my T2. Now this question said to actually determine the volume, which means that you have to actually do the math on your calculator. And so when you do the math on your calculator, it comes out 2.29 with other decimal points. So you can either say 2.29 or 2.3 liters. Number 61 is also based on the same series or same set of information, but this one is asking for one change in temperature and one change in pressure that will make the gas behave more ideal. So if you remember, when we did questions talking about how to make gases behave more ideal, we said that we would base it on our most ideal vacation situation. And the answer sheet said what would be the change in temperature on one line and what would be the change in pressure on the other. We said high temperature, low pressure is the most ideal situation to make gases act most ideal. So you can raise the temperature and lower the pressure. This next set is for 62 through 65. So again, make sure that you are looking at the reading for each of these questions. For 62, for the reading, it says during a titration. Remember, there's a formula on table T for titration. Leave that in the back of your mind. You might need to do it for one of these questions. That also means that it's acid and base reaction. Also, the word completely neutralized tells us something about that. So they want to know the only positive ion in HC2H3O2. So now first, it has an H in the front. That means it's an acid. And in an acid, H plus or H3O plus is the only positive ion in solution for an acid. We call H plus the hydrogen ion. We call H3O plus the hydronium ion. But let's say you had no idea what this was, whether it was an acid or a base or anything like that. You could look at table K. And on table K, you can see that HC2H3O2 is ethanoic acid. We're supposed to know that acids have H plus as the only positive ion in solution. '63 says how many significant figures were used when expressing the volume of the acetic acid. The volume of the acetic acid is 10.00. Since the decimal is present, we start at the Pacific side. Any zeros that are on the Pacific side before the first number that's not a zero are not significant figures. The first non-zero plus everything that goes towards the land is significant. So we have 1, 2, 3, 4 significant figures. For number 64, it says determine the molarity of the acetic acid. So if we just go back to the reading of the question, I'll write that down here. If we go back to reading the question, it says 10 milliliters acetic acid, and it says 12.50 milliliters of 0.64 molar NaOH. When we're talking about titration, remember up there, it says this is a titration. Table T has a titration formula. On table T, the titration formula, which is right here, MAVA is MBVB. Molarity of the H+, which comes from the acid, times the volume of the acid, equals molarity of the OH-, which comes from the base, times the volume of the base. So when we go back to the information that we had, we look at this formula. This is my volume of my acid. My molarity of my acid is unknown. This is my volume of my base, and this is my molarity of my base. So I'm going to do X times 10 equals 0.64 times 12.50. And when I do the math, I wind up with 0.80 molar. You can say 0.8, you can say 0.80, you could say 0.8, 0.80, you could have more zeros at the end. Significant figures don't need to be shown. For number 65, it says, explain why data from multiple trials is better to determine the molarity rather than a data from a single trial. And anytime we have multiple trials, multiple trials always improve the validity or precision of the results. It helps to cancel out error. And it can be shown to be reproducible. It shows that the information is, or that the process is reproducible. So again, look at this, 66 to 68 are all based on the same information. So once again, you want to make sure that you are looking back at the reading for 66, 67, and 68. It says carbon dioxide changes from the solid phase to the gas phase at 1 atmosphere and 194.5 Kelvin. In the solid phase, CO2 is also called often called dry ice. When dry ice sublimes in air at 298 Kelvin, the water vapor in the air can condense, forming a fog of small water droplets. This fog is often used for special effects at concerts and in movie making. So they want to know the heat flow between the dry ice and the water vapor in the air. The dry ice is at 194.5 K, and the water vapor is at 298 Kelvin. So the heat will always flow from high temperature to the body with low temperature. So it's from the water vapor in the air to the dry ice. Heat always flows from an object or a body of high temperature to an object or a body with lower temperature. For 67, it says, at 298 K, compare the potential energies of the water molecules before and after, the water vapor condenses. So before, it is vapor. After you condense, it's liquid. So we know that on the cooling curve, we have gas to liquid to solid. And we're plotting temperature versus time. As gas condenses into solid, when it's just a gas, in a single phase, it's the kinetic energy that's changing. But in the phase changes, it's potential energy that's changing. And because this is downhill, it is exothermic. At each of these times, it's the energy that's decreasing. The energy is decreasing. So kinetic energy decreases in a single phase. Potential energy decreases at a phase change. So the gas is at a higher potential energy, and the liquid is at a lower potential energy. At 1 atmosphere and 190 Kelvin, compare the amount of thermal energy in a 1 kilogram block of dry ice to a 2 kilogram block of dry ice. So they're both at the same temperature. If they're at the same temperature, thermal energy is based on mass. More mass has more thermal energy because they're at the same temperature. For 69 to 72, it's based on the information below and your knowledge of chemistry. Again, notice that you're wanting to reread this for each question, 69, 70, 71, 72. It says a solution of ethylene glycol in water can be used as the coolant in an engine cooling system. The ethylene glycol concentration in a coolant solution is often given as percent by volume. For example, 100 milliliters of coolant is 40% ethylene glycol. That means it contains 40 milliliters of ethylene glycol diluted with enough water to produce a 100 milliliter solution. The graph below shows the freezing point of coolants that have different ethylene glycol concentrations. So explain in terms of particle distribution why a coolant solution is a homogeneous mixture. So remember that homo means same, and it says in terms of particle distribution. So you have to mention something about the particle distribution. So for ethylene glycol, it's a homogeneous mixture because the particles are distributed evenly. There is a uniform combination or a uniform spreading out of the different molecules in the sample. For number 70, explain in terms of molecular polarity why ethylene glycol dissolves in water to form a solution. Remember that water is polar and like dissolves like. So since it says in terms of molecular polarity, you have to either say that water and ethylene glycol have a similar polarity, or both are polar, something like that, because water is polar and like dissolves like. For number 71, it says identify the percent by volume of ethylene glycol in a solution that freezes at -10 degrees Celsius. So for 71, we have to look back at the graph, and we want to know the one that dissolves at -10. So -10 is this line right here. So that's going to come through right around here. And for -10 degrees Celsius, the answer that they're telling you is 21 to 23%. So you could have said 21%, 22%, 23%, and that's for question number 71. For 72, it says one engine cooling system has a volume of 6,400 milliliters. It says determine the volume of ethylene glycol in the completely filled engine cooling system when the concentration of ethylene glycol is 50% by volume. So any percent is going to be part over whole times 100. So we have the whole volume as 64%, and we want the percentage to add up to 50%. So half of 6,400 is 3,200 milliliters. Notice that the next set of questions is going to be covered for 73 to 77. So again, make sure that you reread this information for 72, 73, I'm sorry, for 73, 74, 75, 76, and 77. It's a lot of questions based on the same information. So molecules containing 2 carbon atoms in a functional group have many home and industrial uses. These compounds can be produced by a variety of reactions as shown by the equation below. When they say functional group, you should think maybe I have to look at table R at some point. So it says explain in terms of bonding why the hydrocarbon in reactant 1 is unsaturated. So remember, hydrocarbons have C and H only, and saturated means all single bonds. So this must have something other than single bonds. So you can either say doesn't have all single bonds, or it has at least one multiple bond. That would be like a double or a triple bond. For number 74, it says draw the structural formula of the ethanal molecule in equation 2. So this is ethanol because that's an alcohol. This is going to be ethanal. So ethanal, okay, this is for 74. Ethanal has C with 3 H's because it says CH3, and then a C with an H that also has an O. This O has to have a double bond. If we look at table R and we see where it says aldehyde, aldehyde ends in Al. The last carbon will have this double bonded O and an H on it. So again, C bonded to 3 H's, bonded to another C, which is bonded to a double bonded O, and then another H. For 75, it says, explain in terms of atoms. So we're saying in terms of atoms, which means we have to mention the atoms, why CH3, H2OH, and CH3CHO are not isomers of each other. So isomers have to have the same molecular formula, but different structural formulas. Same molecular formula means the same numbers and types of atoms. Well, if we count this up, this is C2H6O. And this is C2H4O, right? 3, 4, 5, 6, 3, 4. So they don't have the same numbers of carbon and hydrogen atoms. They have to have the same number and types of atoms to fit this first criteria of the same molecular formula. So they have different numbers and different numbers of the certain types of atoms. For 76, identify the class of organic compounds to which the product in equation 3 belongs. So that means that we have to look at equation 3 and find the products. Remember that any chemical reaction, we always have reactants making products. So we're talking about this compound here. So we're talking about CH3COOH. So in order to find out what kind of organic compound CH3COOH is, we're going to need to look at table R. And on table R, we can see that the functional group that has COOH is an organic acid. So we would say that the product in equation 3 is an organic acid. So number 77, says determine the number of moles of oxygen atoms, the moles of oxygen required to completely react with 6 moles of CH3CHO in equation 3. So when we look at equation 3, I just rewrote it here so I didn't have to scroll up. So this is a rewriting of equation 3. When they ask you for a number of moles required to completely react with another number of moles of something else, this is called a mole to mole problem. And the way that different substances react with each other is based on these coefficients. These coefficients are mole ratios. So CH3CHO reacts in a 2-to-1 ratio with oxygen. So it's 2 CH3CHO for every 1 oxygen. So if they want 6 moles of this, then that would be 3 moles, because 2-to-1 would also be 6-to-3. So 3 moles of oxygen would be required. But the way that I taught it to my kids in class is that if they give you a number of moles, you put it over the balanced equation coefficient, and if they ask you about something, you're going to put that in as x. So we can make a proportion, and we wind up with 6, which is the given in the question for CH3CHO. 2 is the coefficient for that. We're being asked about oxygen. 1 is the coefficient of that. And when we cross multiply and solve for x, we still get our 3 moles of oxygen. So for 78 and 79, we're referencing this table. So again, please make sure that you look back at this table and this reading for number 79. It says the hydrangea is a flowering plant. The color of the flower it produces can change depending on the pH value of the soil in which the plant grows. Adding aluminum sulfate makes the soil more acidic. Okay, so aluminum sulfate makes the pH go down because acidic is down, and adding calcium hydroxide makes the soil more basic. Calcium hydroxide makes the pH go up. A student performed an experiment by varying soil pH and recording the color of the flowers. The following table summarizes the results. Identify the independent variable in this experiment. We usually put independent first and dependent second. So soil pH or just pH could be my independent variable. The next question, 79, says hydrangea plants can be grown in soil that turns litmus red. What color are the flowers in the plants grown in the soil? So we're going to want to look at table M to determine the pH when litmus is red. So on table M, what we want to notice is that if we're looking at litmus, it says that it goes from red to blue. That means that it is red before a pH of 4.5 and blue after a pH of 8.3. So the pH for when litmus is red is anything less than 4.5. If we look at another one, for example, methyl orange is red at a pH below 3.1. It's yellow at a pH above 4.4. And orange in this middle range. So now the next part of the question was, what color are the flowers of the plants grown in the soil? So we're going to need to look at that table to find out what color are the flowers in a pH of less than 4.5. So here is that table that was with the reading. Remember I said you always have to look back at the reading for every question that is based on that reading. And if we look, less than 4.5 is going to be a flower color of blue. So we're going to say that the flowers are going to be blue, sorry about that, for number 79. For 80 to 82, it says it's based on this voltaic cell. So once again, we want to make sure that we keep looking at this voltaic cell for all of these questions. Now on the regents, they'll be grouped all together right in a row. So it'll be a little bit more obvious than on my copy. You can see on your copy that there's a dark line at the end of the questions that go together. So it says the diagram and balanced ionic equation below represent two half cells connected to produce an operating voltaic cell in a laboratory investigation. The half cells are connected by a salt bridge. So if we look at this, remember, we're going to have an anode and a cathode. So magnesium is going from 3 up to +2. So we're going to call the magnesium electrode the anode because the metal was oxidized and the charge went up. That means that we're going to call the copper the cathode because the charge of the copper is going down. The electrons are going to flow through the wire from anode to cathode, from magnesium to copper. Ions will flow in the salt bridge. So it says for number 80, determine the oxidation number of nitrogen in the negative ion in the aqueous solutions. So let's look at NO3 on table E, and NO3 has a charge of negative. So that means its charge is -1. That means that the nitrogen and oxygen's oxidation numbers and charges together will add up to a -1. So we said that for oxygen in a compound, oops, I don't know why I wrote ox. For oxygen in a compound, we're going to put a -2 charge except for BaO2, H2O2, and OF2. As long as it's not one of those compounds, we're going to plug in a -2 for the oxidation number for the oxygen. Then remember, we multiply down in order to get the total charge. Some number for the nitrogens is going to add with a -6 to get us to a total charge of -1, because NO3's oxidation numbers have to add up to the total charge on the ion, which gives us a +5 for the nitrogen because there's only one of them. So this total number down here divides by the subscript to get back up to the oxidation number at the top. Number 81 says to state the purpose of the salt bridge. We said that the salt bridge allows for the flow of ions. Ions are going to move in the salt bridge, and they're going to keep the anode compartment and the cathode compartment from becoming charged. For number 82, it says to explain in terms of atoms and ions. So anytime they say in terms of, we have to mention why the mass of the Mg electrode decreases. We said that magnesium was the anode, and we said that the other element, which was copper, was the cathode. I just realized they're on opposite sides. So we said that the copper was the cathode. Got a little bigger. So if the magnesium is the anode and the copper is the cathode, we use an ox and big red cat. The anode is oxidation, the cathode is reduction, and the cathode gets bigger. If we look at the balanced equation, we can see that as the reaction proceeds, magnesium solid, which has atoms, is producing magnesium aqueous, which are ions. So atoms at the anode are turning into ions in solution. It gets smaller because atoms are losing electrons to turn into ions. On the other hand, the cathode gets bigger. So this on the left here is the answer. But if they ask you why the cathode gets bigger, for the cathode, the ions in solution turn into atoms at the surface of the electrode. And finally, for 83, 84, and 85, this is the last set of questions. Remember that there are 2 other videos going over this same January of 2017 exam. And if you've liked the videos and the videos are working for you, you can certainly look on my YouTube channel for some other ones or subscribe to the channel. For 83, it says complete the equation for the nuclear decay of MO 99. Remember when we do these that the arrow acts like an equal sign, so we're going to do 99 equals x plus 99. This top number over here will be whatever adds to the number that's already here to get the top sum on the other side, and that's going to be a 0. 42 equals x plus 43. That's going to be a -1. 43 minus 1 is 42. 42 is 43 minus 1. And if we look at table O, the symbols used in nuclear chemistry, 0 over -1 is going to either be a B for beta or an E for beta. So either one of those symbols will be good to fill in either the lowercase e or that symbol for beta. In our class, we usually did the 0 over -1e, but the other ones are acceptable as well. So the big thing here to remember is that the equal sign, the arrow, is like an equal sign. So we are going to do 84 now, and we're going to make sure that we read the question again when we do that. And it says to state both the number of protons and neutrons in a TC99 nuclide. So in order to look at this, we want to make sure that we know how many protons there are. Since an atom of the same element has the same number of protons no matter what, we're going to find TC's atomic number on the periodic table. And when we look on the periodic table and find TC on here, we see that the atomic number for TC is 43. So what we're going to do is do mass number minus atomic number to get the neutrons. The atomic number is the number of protons. The mass number minus the atomic number gives us the neutrons. So we have 43 protons and 56 neutrons. And the final question on here, number 85, it says determine the fraction of an original sample of the metastable TC99M that remains unchanged after 24 hours. So this is going to be a half-life question. And if you look back up at the reading, in the last sentence it says the half-life of the metastable TC99M is 6 hours. So we're going to always take the amount of time for the total time divided by the time for one half-life to find out how many half-life periods go by. And remember that the number of half-life periods go by is the amount of times that it divides in half. So after the first half-life, we have a half remaining. After the second half-life, we have a fourth remaining. After the third half-life, we have an eighth. And after the fourth half-life, we have 1/16. If you're having trouble visualizing that, after one half-life, we have half left. After two half-lives, we have half of that half left, which is a fourth. After three half-lives, we have half of that fourth left, which is an eighth. And after four half-lives, we have half of that eighth left, which is a 16th. So if we did this, we had half, then a fourth, then an eighth, then a 16th. So it's 1/16 remaining. So hopefully this was helpful for you in going over. This, remember, was the January 2017 Regents. I do have 2 other videos. This was the third in a series. So there is a video going over 1 to 30, and there is a video going over 31 to 50. This video was 51 to 85 for the January of 2017 Regents. If you visit my YouTube channel, Mrs. T, Chem Talk, if you Google that with YouTube, just in Google, my channel should come up, and you can find many more review videos for Regents Chemistry, and there are some videos for AP Chemistry as well. Good luck studying.